into our data analysis. Now, qualitative data, remember, is what? Words. Right? Excel cannot read these words and analyze the data. Okay? But what we can do is take these words, these questions, and turn them into numbers. Okay? So let's say we have a question that is yes or no. In order to take a yes or no, we need to create what's called and this is the official term, we need to create dummy variables. Dummy variables are going to take a value of either 1 or a 0. It doesn't matter which it is that you choose to do. You could say, I'm going to create a dummy variable, and it's going to take the value of 1 equals yes, and 0 equals no. Okay? And then we just treat that as any other independent variable. Right? Just like how we would treat the age, we can treat the dummy the same way as it's 1 or 0. Alright? That's for yes or no. Notice how many dummy variables we have. 1. We only have 1 dummy variable if we have 2 possible answers. Okay? So you're always going to have 1 fewer dummy variables than possible qualitative answers. Right? Because we always need to compare it to some benchmark 0. Everything that has a 1 is always in relation to the 0. Okay? Now, to try and illustrate this point, what if we have, say, gold, silver, bronze? If we have 3 different variables, say we have gold, silver, or bronze, we always need to create 1 fewer dummy variable. Okay. So in this case, how many dummy variables do we need to create? 2. Right? I can have dummy gold, right? And I'm going to have gold be 1, 1. Right? 2 different numbers. And bear with me here, I'll flesh this out. Right? Dummy silver could be 1. Wait, no, sorry. 1, 0 for gold. Dummy for silver could be 0, 1. And then our dummy, or then our bronze by default would be what? 0, 0. All right. So what I would do if I wanted to create these dummy variables?
We have some on hot dog.
What's that? All right. So here's an example here. So we have the demand for hot dogs, the temperature, the price, and a dummy variable for is it during the day. So what this is saying is it equal 1 if it's day, otherwise it's 0, which would indicate night. All right. Now let's look it up here, and then I'll add one that has 3 different options here. I'm looking to explain the demand for hot dogs. So what is my dependent variable? Which of these are my dependent variable? Demand. Temperature, price, day. Let's go ahead and just do our regression analysis. Go to data, data analysis, regression. Okay. In our dependent variable, we highlight the y. For our independent variables, we highlight the 3. Notice I included the day in there as well, this dummy variable. Right? A yes, no question. Is it during the day? 1 for yes, 0 for no. Right. Labels, confidence, output range. Okay. Notice everything should look similar to what we saw before. We know how to analyze this. Right? This isn't scary when you guys see this anymore, correct? How do we interpret this really quickly? Okay. Temperature. As the temperature goes up by 1 degree, what happens to the demand for hot dogs on average? The demand goes up by 1.16 hot dogs. So every degree it gets hotter, there's higher demand for hot dogs. Okay? As the price goes up, this is pretty strong. As the price goes up by $1 for a hot dog, say it's $1, it doubles to $2. What happens to the demand for hot dogs? It goes down by 84 hot dogs on average for every $1 that you increase it. Okay? Very price sensitive hot dogs. Now day, remember I said the dummy for day equals 1 for day equals 0 for night. So everything is compared to our 0 value. Now the coefficient here is 24. Interpreting our dummy variables is important. What does this mean? Okay. If it is a day, the demand for hot dogs go up by 24. Right? So daytime demand is 24 hot dogs more than not daytime, by nighttime. Alright? So this is in comparison. So 1 would be day and 0 would be night. Let me show you in a different way. I'm going to write out my regression equation. So demand for hot dogs equals 98.7 plus 1.16 temp minus 84.3 price plus 24.1 times day. Right? You guys see where all these numbers come from? I just wrote out my regression equation. So forget about this and let's focus on day. If day equals 1, the demand, well, you have to add that 24.1 if that's 1. Now if day is 0, guess what happens? That 24.1 goes away and the demand is less by 24 hot dogs. Right? Everything is relative to that 0. Does it matter which is which? The answer is no. Right? You could always let night be equal to 1 and day be the default 0. Then you're looking at how does it change if it's night compared to day. Here we're saying if it's day, which is 1, there's going to be on average 24.1 more hot dogs demanded compared to all else equal, same price, same temperature, but at night. Okay? So that's how we incorporate qualitative data.
So
Go ahead.
just so I can wrap my brain around it.
Yeah.
So on average, you need 98.72 hot dogs, quote unquote, per day. Unless the temperature goes up, then you need.
Okay. It would be, the demand would be 98.7 if the temperature is 0, the price is 0, and it is night. That's the only reason why that would be this intercept, which that doesn't make any sense.
0% change in the temperature.
So let's do-
The same as the average temperature, so if the average temperature is 70, so you're saying.
So let's say the temperature doesn't change, the temperature is 70. Okay. And the price is what? $1.25 for price. Okay. What is the y hat for day? And what is the y hat for night? Holding everything else constant. Okay? So for day, it would be equal to the intercept plus, this is exactly what we did before, plus temperature times the temperature, the marginal plus times the temperature, plus the coefficient on price times the price, plus the day times 1, because 1 was day, 0 was night. So this coefficient on day times 1. Okay? So the demand during day for the hot dog would be 98.88 hot dogs. Okay? Now what would the demand be at night, all else equal? It would be equal again, we're going to do the same exact thing. Intercept plus temperature times the temperature plus coefficient on price times the price plus coefficient on day times 0, because 0 is night. Right? 1 for day, 0 for night. Notice that's 24.1 less. Right. So same temperature, same price, daytime demand for hot dogs on average is 98.8. Same temperature, same price, but at nighttime, 74.78. Yep.
So to read it just off of the, I don't know.
Sure.
The intercept, so the way that you would interpret that is that the demand is 98.72 unless the temperature goes up by 1.64 or the price goes down. I'm confused how we're reading that.
You're confused about these up here?
Yeah, just like how you would just say it works.
Okay,
So like,
it works. If the temperature goes up by 1 degree,
okay.
demand for hot dogs will go up by 1.16, all else equal.
Okay, and if the price
Goes up by 1, the demand for hot dogs will, finish my thought, if price goes up by 1, the demand for hot dogs will
go down in demand by 84.34,
all else equal.
all else equal.
Yep. If it is daytime demand will be 24 hot dogs higher than nighttime demand, all else equal. Yep.
So you have to say all else equal.
Correct, because now we have multiple things, so what these are looking at is isolating the individual independent variables, holding the rest of the independent variables constant. So we're just focusing on changing one, holding everything else constant, just change temperature. Everything else, just change price. Everything else will just change day or night. Okay. Now let me show you another example. I think I have it here under Camry 4. Excellent, good. So this is an example of, going back to my Camry here, we have the mileage and age. This is the exact same thing that we had. This is, I think, Camry 4. But now we're looking at Josh Hall's Camry, looking at the mileage, looking at the age, but then what condition is my car in? Is it excellent? Is it good? Is it poor? Notice that's qualitative data. Notice that is 3 possible options that my car can be. I put up here gold, silver, bronze, but in this case it is excellent, good, or poor. Okay? Now what we have here, I can read this, just looking at this. I need 2 conditions because I have 3 possibilities. Excellent, excellent, good, or poor. And I need 2 dummies, so dumb 1, dumb 2, correct? What is my dummy 1 and 2 if it's excellent? So find excellent, what do I have here? So the top one's excellent. It's 0, 0, right? So excellent is the default. Excellent is 0, 0. My default. Everything is now, remember before everything was compared to relative to night. Now everything is relative to excellent. Alright? Oh, good. So right at the line in the board. Good is what? 0, 1. Okay, good is 0, 1. And if you scroll down to see a poor, poor is what? 1, 0. Notice how we're codifying all these qualitative things. 1, 0. So we have all of our options. There's never going to be a 1, 1. It will really confuse Excel and make no sense. Okay? Now, let's interpret this because I think this might really help solidify. Remember, excellent is our benchmark, our default. Yeah, I think you're really going to like this here. Let's do it all together, practice it. Data analysis, regression. My dependent variable is the price, correct? So we're trying to describe the price of the Camry. Okay. Now my independent variables. I start with mileage, and I highlight mileage, age, condition 1, condition 2. Don't put the words good, excellent, and poor, and that's what we codified it for. It'll really mess it up. Labels, confidence, output range. You're going to like this. I'll give you a second to get what I have. And we have this. Notice my coefficients for intercept, mileage, and age change from the original. Why? Because we added more variables that changes the marginal impact of the other variables. Every time we add, it changes. Alright? I like this. I like this. Condition 1. Which one was a 1 for condition 1? That was poor, right? So condition 1, this is poor, poor relative to excellent, all else equal. So if this, looking at this condition 1, so this is going to be the difference in the value of a car with the same mileage, same age, but one is excellent condition and one is poor. Right? It's going to be the change in value. And condition 2, well, where's the 1 there? That's good relative to excellent. This is good. Alright. All else equal, mileage and age. All else equal, same mileage, same age. A car in poor condition is worth $7,695 less than same car in excellent condition. Everything is relative to the 0, 0. All else equal, and by all else equal I mean the mileage and the age. A car in poor condition is worth $7,695 less than a Camry with the same mileage and same age but is in excellent condition. Because condition 1 we know represents a poor relative to an excellent. Now read this for condition 2. This is the good car. All else equal, a car in good condition is worth $5,637 less than the car with the same mileage and same age that's in excellent condition. Right? So we took these variables, created dummies. You can have so many, some of my research I've done, I have created dummy variables for the region of the world, including, so I would have advanced, I would have South America, I would have Asia, I would have Africa. So if I have, or say North America, so North America, South America, Europe, Africa, East Asia, South Asia. If I have 6 regions in the world, how many dummy variables do I need to create? 6 regions, I need to create 5 dummies. Because I have to have a 0, 0, 0, 0, 0, a 1, 0, 0, 0, 0, a 0, 1, 0, 0, 0, a 0, 0, 0, 1, 0, and a 0, 0, 0, 0, 1. Right? Because it's always 1 less. And that way I can distinguish, compare each region compared to my default, my all zeros. Right? So it's always 1 less.
This may be a really stupid question, but so our intercept is that, what exactly is our intercept? I'm confused on that. What is the, I know what it is on like a graph, but like what is the intercept?
Nothing. Nothing. It is the value of the car if everything else is 0.
Oh, okay.
So it means nothing.
Okay.
It's kind of like a benchmark where we start our linear things.
Okay.
So clearly this would be a car, this might, in the car example, this is perfect. A car that is just brand new, just made. It's excellent condition, so the conditions are 0, 0. It has never been driven, 0 miles, and 0 years old. This car, as soon as it comes off the lot, never driven, is worth $29,903.
Which is odd, because you skewed the number at the beginning by having a 27, the highest value, having a very high mileage rate, being 2 years old, in excellent condition.
Say that again?
So the one with the highest value is 27,995. It has 52,000 miles on it.
Oh, correct. These are all, every Camry is different. Every person drives differently. My Camry has a nice thing about the miles per gallon, and it says, are you being fuel efficient? Right? Maybe a driver is that who always is fuel efficient. Some people like to peel out or, treat their car poorly. Right? These are just individual, your car, your car, your car, your car. So correct. The value of it, the price of it could be different for a number of reasons. Right? These are all just individual, and this is looking at the average marginal effect. So yes. Even though that car is in real life worth more, well, it's actually less than what the brand new car would be. But that interpretation to answer Abby's question, that's what it is. It would be a car zeros, everything is zeros. That would be the intercept. Yeah. A couple issues that we have when it comes to this, and if I don't get through all of chapter 16, that's fine. I can finish that up. It's only about a 45-minute lecture. A couple things that we want to watch out for when we do this. And there's a lot of examples on here about how to do. Well, first of all, any questions starting to make a little bit of sense? If we still have Thursday. Unless you want me to get the exam on Thursday.
No.
Then we have 3 hours to make sure that we're ready for next Tuesday. Okay. Some issues that we want to consider, and when you're doing your paper, keep your eye out for these type things. Right? Some drawbacks or some considerations. So there's a number of issues that we can look for, a number of drawbacks.